Okay, seems like it's recording. Yeah. Okay, I hope it doesn't stop recording soon. So Freddy, also, do you want to show something to the students? I have some examples ready, but do you want to show something also? No, okay. So guys, I prepared some examples for you. Everything is already inside the Google Drive folder, and it's also linked in the wiki, in the local class. So you can download them from there. Can you tell me if you see my screen?
Yes.
Yeah, okay. So this is the folder I'm talking about. It's inside Week 13 networking, and there are some slides with some already done examples and some links that we can look briefly. Maybe just to have more information about the different protocols, some definitions, and the way that they work. And then we have also some example code. I prepared these example codes for all these protocols, and some of those I wrote them myself. Some others are just corrected and modified examples taken from the internet. The links are also inside the code, so you can go back to the example online to check it. Yeah, so this is the example from Neil that uses the serial, which is actually the first protocol that we will look together. And as you can see, he also uses some libraries. These libraries are C libraries, and they come from standard libraries like UT, or they are from EVOR libraries. So EVOR are a collection of libraries, especially developed for the EVOR microcontroller, if you are curious about them. I was introducing them in the lecture about C programming, and there you can also find a link for the functions that we have inside. So going briefly through this one, you can see that Neil implemented, as Ferdi said, a serial protocol directly in C, because it's not complex to do so. And it works by using these different statuses of the pin, so it can be high or low. And here is like composing the protocol together with this if, and then with this bitewise operator, shift here or over here and so on. So I don't want to confuse you, but you should really start learning a little bit of C, and then making, of course, also your own PCB design. And then we can go deep to this level over here. So here we don't have set up a loop, we have main. And inside the main, what it does, it has this forever loop. It does first some initialization over here. These are some initializer for the clock divider. So all these strings are built-in keywords inside the libraries, for example. And then here in this while that you can consider similar to the loop that you have in the Arduino, it does all the business of the communication. Yeah? So here there are many different things. There are the pointers, the address of the pointer. There are pointers, arrays, and so on. So we will do the same in a simple way now with the Arduino libraries, and then once you practice a little bit, we can go back to this one. We can have also more additional lectures apart from just once per week, so we can go deep as much as you want. Okay, better on. So here are the slides. In the slides, you will see some basic examples about the protocols and the networking. This list is not exhaustive. Actually, in the examples I prepared for you, I also work with some NRF radio modules that could be very useful for the project from learner because he wants to work with a drone. So few words about serial that you should understand is that serial has been developed to work only between two devices. Is one of the most easiest and ancient kind of communications that you can find, and does not require a lot of computational power to be implemented. So it works in a lot of different small and embedded microcontrollers. So some microcontrollers have the serial port as an hardware device inside the chip. So this is the case of the Arduino chip, the ATmega328P, of the new ARM microcontrollers, and so on. And when you have an hardware serial port, you can communicate quite fast. And then it's still used to communicate between microcontrollers, or even to communicate between microcontrollers, for example, and the computer. So nowadays, computers, they don't have anymore the serial port. They have only USB. So usually what we do is we convert the serial data into USB data with a USB to serial converter. So serial offers you also a full duplex communication, which means the two devices can communicate simultaneously together. And therefore, you could have like some data thrown in one of these RX or TX wires, and then it's up to the receiver if he wants to read it or no. And this can be done simultaneously. So connection-wise, you only have two wires, transmitter and receiver, TX and RX. And then to make sure that the logic levels are something that the microcontrollers can understand in the communication, you need to share the ground between the two microcontrollers. So the connection schema is rather easy. It's just RX and TX, and then you have a ground cable. With the implementation of the serial inside software that you can do the way that Neil is doing it, or you can do it by using, for example, software serial library as this simple example. You could then use any other digital pin to implement a serial port. So by default, in the ATmega328P, you have one hardware serial port. But you can add another serial port by using the software serial, the same as Neil is doing with his own code in the microcontroller. So in that case, he is doing that because the ATtiny doesn't have a hardware serial port. So you need to implement it in software. So then here the example is much more straightforward than the one from Neil that we just had a look briefly before. It uses basically the built-in serial library from the Arduino, which is called serial. And then it also uses another built-in library, which is the software serial that implements the serial into any other digital pin. So what we do here in this code is rather easy. We include the software serial library. We initialize the software serial library to be in these two specific pins. So 10 will be RX and 11 will be TX over here. And then inside the setup, we initialize the communication. So what you place as a parameter inside the serial.begin or the software serial.begin is the baud rate, which is basically the speed, the communication speed that you can have. You have to be warned because when you implement the software serial, you have a limitation on that. And the same is the way that Neil is doing. So the software serial cannot go fast as the hardware serial. And then, for example, in case of the Arduino library, 9,600 as a baud rate, it's already on the limit. You could have some problems for the software serial with that speed. Instead, in the hardware serial, you can go much faster than that. I think I usually go, for example, 250,000 as baud rate, and then you can communicate much faster. Then in the loop, what we do is we use the print function, which prints strings. Take care of that for the communication with Python or processing. Print strings to the output. So in this case, this print function, it's available both for the hardware serial and the software serial. So here what we can do is, okay, we use this serial to send a message to the other board. Then we wait 1 second, and then we wait that the other board responds here if there is something on the serial buffer, and then this writes this back to the my serial, which is then the software serial. So one thing that is important to notice is that whenever you send data through the serial communication, this will be received in a serial buffer from the receiver. So you know the status of the pin will change, and then this will be, let's say, recorded from the receiver pin on the other side. But there is a limit. So for example, in the Arduino libraries, this limit is 64 bytes. So this means that anything that you send extra 64 bytes is going to be scrapped out. It's going to, let's say, be lost in the receiver. So take care that you don't overflow this 64 bytes buffer in receiving. Yeah. So you can do this with 2 boards. You can do this with your own self-made boards. You can have more than one software serial. So as Ferdi said, that is very important at the beginning, the library is eating memory. So for the T28P or some at the time is fine to use the software serial. Otherwise, the way that Neil does directly with this simple function, for example, get a char from the serial, it's much faster and it has a much lighter footprint on the microcontroller memory. So again, this is going back to the fact that if you program in the lower level, you're going to have, of course, much more efficiency and much more memory available. Okay. So I told you that serial was developed to work between 2 devices, but with some tricks, you can also make it work with more devices. If you think about having one of these Arduinos or PCBs as a node that can receive one byte, for example, and then send this byte to the next node in case, for example, this is not for himself, but for another board. So what is important also, because it's between 2 devices, is that the devices, they don't have any address. So basically, anything that is connected on the other side of the 2 wires will receive the data. So then you can implement a sort of addressing by using some code, some programming code directly yourself. So you can say, if this data belongs to the node number 1, and I'm node number 2, please forward this to node number 1, for example. Okay, so you can make also a connection with more devices. This was one of the examples from Neil. This comes to another important point, that is in the assignment, guys, you must make a network with addressing. So if you just use the serial as it is, like in this example, it's not enough to pass the assignment. You should implement, in the case of the serial, some hardware identification of the node. William, more question about serial communication? About the protocol itself, or?
No, I'm good. Oh. This much I understood.
Hannes, Gerard, Ferdi?
Yeah, I was just laughing a bit in between because of the TX-RX pin, because I didn't install the headers to them.
Yeah, the TX and RX, guys, are transmitter and receiver pin. And one thing that you should, one super stupid common mistake that is often done is, apart from forgetting from the board,
is connecting TX and RX to RX, which, yeah, of course you have to. So the transmitter goes to the receiver, and the other transmitter goes to the receiver of the first board. So of course it needs to be this way around.
Yes, very good. especially when you make connection onto the board. Maybe that you try to program the board with the FTA cable, and then you go crazy. Oh, why doesn't work? Just switch the cables. Okay. So the second communication that I will talk about is the serial peripheral interface. And even if you might think that you never worked with this protocol, you for sure have already worked with it, because it's the way.
Assignment.
Sorry?
So we've already done this assignment in the electronics production week.
Okay, very good that you understood where it was used, but in that case, somebody has implemented the code to use the protocol. So in this case, you should also implement the code. Very well. So in this case, the serial peripheral interface for the EVOR microcontrollers, at least, it's used as a standard way of uploading the code that is going to the flash memory of the microcontroller. But this does not mean that you can use the SPI communication also for your own networks. So what changes in comparison to the serial is that you can connect more than 2 devices. So this is the first thing that you should realize. The second thing that you can realize is that there is a sort of hierarchy in the network. So this means that you have from one side a master microcontroller, and the other side we have a set of slaves microcontroller. Also, in comparison to the serial peripheral interface uses more connections. So the connection that you might remember from the programming are the following. Let's see, arrange, order, bring to front. These are the connections that you're going to use. So let's go briefly through them. So CS is slave select or cable select, and it's basically a wire that is dedicated in identifying the slave that you want to communicate to. Then SCK is the SPI clock. Clock means, in this case, that there is a specific frequency to which the protocol can send and receive data. So in this case, when you start communicating in SPI, you have to define a specific clock frequency. Of course, this clock frequency cannot exceed the clock frequency of your microcontroller, and it's often just a division of it, so it's often just a factor of it. Usually it's divided by 8 or by 4, and so on. So this means that multiple boards with different clocks can communicate, and that you have to lower the clock in case the other board cannot reach the clock that you have. So you can set the clock, we will see this later in the code. So then you have the 2 communication pins, which are MISO and MOSI, and they are basically dedicated to the protocol itself, according to the clock. So one is master output, slave input. One is master input, slave output. So in this case, you can also see that the limitation of the number of slaves that you could have depends on the CS pins that you have available, because you need 1 CS pin for each new slave that you want to connect to. Of course, if you just have 1 board, you don't need this cable select. But if you're going to have more than 1, like in this image over here, then you need the cable select. So the cable select is again a dual state pin. You just go high or low to select one of the slaves, and vice versa to deselect it. So in this case, the communication can happen only between 2 boards simultaneously. So the master says, okay, I will select slave 2, and then I will tell him the clock, and I will start talking to it. Then I will stop talking to the slave 2, and I will talk to slave 1. So this means I will change cable select 2, and I will select cable select 1 here. So this means that the communication can happen only between 2 boards at the same time. So it cannot be that the master talks to 2 slaves simultaneously.
Well, why not?
Because you need to have the cable select to work with it. Also, this communication is full duplex. So if you want to keep that, you need to do like that. Otherwise, you can do just broadcasting.
Yeah, but you can broadcast, right?
Yeah. You can do some broadcasting, but then you cannot have this full duplex communication, because on the way back, I think Neil also mentioned this in the serial protocol, that, okay, on the way to, so from the master, let's say, or from the transmission pin TX of the serial, you can spread around, you can set the clock and so on. But then the other one, when they will send back the data, there can be some collision if sending back simultaneously. So maybe I didn't mention it, the broadcasting, for example, for serial is another way of having multiple, more than 2 devices connected with the serial. So in this case, the other way was like, okay, having identifier nodes, you receive some data, I'm the node number 1, no, I will forward this to node number 2, let's say. The other way is to connect everything in broadcast. And then for the way back, here and here also, you can think of about some like time sharing sessions where every slot, somebody else can talk back to the master or to the other serial node. Well, we can talk more about this when we see I prepare some physical examples for you guys that you're going to see live. Okay, let's have a look to the code. Maybe another thing that is worth to mention is that both the serial, the SPI, you will see all the protocols are not only useful to talk between 2 microcontrollers, but sometimes they're useful to talk between the microcontroller and a device. We will see the Bluetooth and the Wi-Fi modus. They talk using serial communication. The SD card reader works using serial peripheral interface. The accelerometer works through I2C and so on. So then you have master and slave, and there is also here a SPI library that you can use from the Arduino. So this is a very simple code that you have from the master. They kept some kind of like consistent naming in initializing the communication. So you can just, for example, do SPI.begin and include SPI.h here at the top. And then you can set the clock over here. So this SPI clock divided by 8 is a keyword on the Arduino library that you can use to divide the clock by 8. There is also like a default clock, if I'm not wrong, it's 4 megahertz. If you have an Arduino board.
Why do I want to do that?
Because you want to make sure that the other board can use this clock. So maybe you are communicating with a board that is 8 megahertz. So the minimum clock of the Arduino boards, if I'm not wrong, is 8 megahertz. So they set this like to 4 megahertz or less to make sure that you can communicate with the other boards. Yeah, William.
So I'm still not quite sure I understand why I'm dividing the clock. This was a step that's beyond me.
Yeah, so the step behind is that this communication uses a clock to organize the transmission.
Yeah.
So, and you have to agree on a clock before starting transmission between 2 microcontrollers. So if you're talking between a board that has 8 megahertz and the other one is 16 megahertz, the one that has 16 megahertz is forced to lower the clock to talk with the one that has 8 megahertz. They cannot talk at 16 megahertz both. So what you do is you divide the clock from 16 megahertz by a factor to make sure that you can talk with the other board.
Yeah.
Okay, so sorry, the code here, let's continue to it. So what you do is you have to enable one of the slaves. So in this case, in the slave select or cabo select, as you want to call it, when you write low, you enable that slave. So you might have multiple slaves connected over here. And then what you do is, okay, you write, in this case, this is a string. And then you write every character of this string inside this 4 over here. And then with SPI.transfer, you send the byte, so the character, and then you print it. And then at the end of this one, you deselect the slave, putting this as high. And then 2000, okay, 2 seconds wait, and then you go back over here.
Okay, so hang on a minute here. This thing, if I've understood right, the serial.begin at 11.520, 5200, that's going to communicate with the computer, correct?
Usually, yes, for the bug, so you can see what's happening.
Right. So the serial connection, that serial begin and the serial print that we're going to see later, those are just debugging things. What matters in the SPI connection is the digital write, then the SPI begin, and then the clock divider, which is essentially just setting the baud rate for the SPI. Is that correct?
Yes, it's the data rate, but this in this case is not defined in bytes per second or something like that.
No, but it's in clock ticks. Yeah, no, I get that. But it just then says that the set clock divider in SPI is essentially equivalent to setting the baud rate in regular serial.
Correct.
Okay.
That's the speed of communication, let's say.
Right. Okay. So then in the void loop, we're going to define a character. We're going to write to now, what is port SS? Where did that come from? As that's the slave select. Is that sending the code to the CS port, to the pin? Is that what that's doing?
Digital write is the same as you use for the pin, for the LED, to put it on and off, no? So basically, we are sending low to select one specific slave.
Yeah, but what is SS?
SS is just a pin. It's just like.
Well, where did we define that? Did we define that outside this piece of code?
So this one, yes, it's. I think just the example they forgot here to put the SS.
Okay.
Just
and SS.
That pin 13.
SS would be. It would be the pin that you've labeled CS1 or CS2, correct?
Correct.
Okay.
So yeah, over here. It's just any other pin basically. Yeah.
Yeah, but it's the one that you've got connected as CS1.
Yeah.
Okay.
It's called CS or SS, slave select, cable select. That's the name. Okay, so this was the master code. Yeah, so, and then here you have some slave code. Yeah. So, and then you have here some ways of turning the SPI in slave mode or master mode. So this code is actually like a mixture of C and the Arduino libraries. And then here, what to do is much more complex. You still have setup and loop. But then here with this code over here, this bitwise operator, you turn the SPI in slave mode. And then you have here an interrupt on the SPI that you touch. And then you have an interrupt routine. So this means that every time that there is something on the communication, this interrupt routine will be triggered. And this interrupt, guys, it's something very useful for the button. I think for you, Hannes, we were talking about it because it's able to interrupt the code wherever it's running instantly without waiting if you are in a digital read mode. Yeah, and then this means that every time that the interrupt will be triggered, that you receive something on the SPI, this routine will be executed. And here we read this byte C from the SPI data register. And then here we put it in a buffer. And basically then at the end, we put here a /r, which is like return. And then this is our routine that reads, that accumulates the data into a buffer. And then
Bye-bye.
Sorry?
You're back.
Yeah. Okay, sorry. And then, so here we accumulate the data received in this buffer here. And then in the loop, we print this buffer over here. So CFA for interface can be done in different ways between different slaves as well. If you want to play with it, I recommend you to start from the SPI library or some pre-made examples. And then this example that I'm showing here is already a little bit more deep because it uses this register from the SPIs to make it work. There is in the link the reference also to the SPI library from the Arduino itself, and there are also some simpler examples than this one. Yeah. Okay. So in this case, here there are the connections between the boards. So MISO, MOSI, in this case, are the pins from 11, 12, and 13, and so on. But then you can use here as a slave select any other pin, and so on. Okay. So guys, I think there are also some examples from Neil for the SD card reader. So the SD card reader works with SPI.
Okay. Is it only me or?
No, it's not only you.
No,
And
we're all
Daniela,
still
you're
here.
there?
Daniela has gone walkabout. It's his SPI communication has failed.
Slave select.
The slave has unselected himself.
Yeah, I'm still having problems in seeing the shared screen. Like I spent the last while trying to debug it, but there's no way I can see the presentation. Like if anybody knows any trick of how to make it,
ask him to.
The broadcasting of the serial with 3 state doesn't work with telecom. Yeah. Okay. So sorry guys, I don't know why. Do you have more questions about the?
No. We thank you very much for giving us a coffee break. That was very kind of you.
Yeah. Do you have more questions about the serial peripheral interface?
I think we're okay as long as, can I summarize? We have our MISO and our MOSI. Those are the data, those are the equivalent of transmit and receive, correct?
Yes, something like that for, yes. With a different
and then
protocol.
and then the S clock thing is telling us that's the sort of, there's data to be had. And then the CS is the addressing, right? So an SPI device doesn't have an address so much as it has a pin it's waiting to hear high or low, correct?
Yes, it's a hardware address, let's say, because you have.
Okay. Well, it's not even an address; it's really just an on-off, right?
Yes, but then you have different pins. So the pin
right. Yeah.
A pin to an address, let's say. Yeah.
Right. So you need as many wires as you have devices.
Yes, that's a delimitation, one of the biggest limitation of SPI. Because if you have, of course, a tiny with 8 pins, you cannot have many slaves as one that has 100 pins. Another thing, I was looking the SS, why it's not defined in this example, William, and it's actually the pin number 10. Look, it's a predefined pin from the library. It's a string from the library, let's say, a keyword from the library.
Okay.
That is 10. That's why when you program your board, you use 10 also as pin from the Arduino.
Can I change that?
Sorry, can you hear me?
Can I change?
Yeah, of course. You can change that with whatever pin you want. Just don't write SS, you write, I don't know, pin 13, 14, whatever. Sorry.
Yeah, writing SS isn't a thing in Germany.
Yeah. Okay. But it can be any pin, of course, the cable select.
Right.
Okay, guys, the inter-circuits or inter-integrated communication or I2C invented by Philips is having some more functionalities in comparison to the serial peripheral interface because the main difference is that you don't need that many cables with the clock and everything. as the SPI to make the communication happen. So first of all, you can have multiple masters, you can have multiple slaves, and you just need two cables to connect the boards together. In this case, SDA and SCL. So the communication here is much more like a bus, where you have these two cables going around within all the microcontrollers. So this is another example over here. It's just one unique image here. Maybe let's quickly remove this so you can quickly see it over here. So you have basically like one master over here, and then you have just two cables, and this is like a bus, and this passes through the all boards over here. So this sets you a lot of cables in case you want to have more than a small number of slaves. The standard protocol, I think it works for more than 100 devices. The one that you can use with the library of the Arduino, for example. And then this means that you don't need 100 cable select pins, but you just need two cables to connect everything. The drawback of the I2C is that the communication is not full duplex. So this means that not only two devices can talk at the same time, so it cannot be that multiple slaves talk to the master and so on, but also it can be only sending or receiving. It cannot be simultaneously sending and receiving here. So it's slower than SPI in this perspective, that you cannot simultaneously send and receive data. So again, I2C is used in a lot of devices. It's used in the accelerometer, for example. As Neil was mentioning, you can read the data from the register of the connected devices. And you might think of this protocol not only to make a network of boards, but also to make a network of sensors. So if you have multiple sensors connected in I2C, let's say you want to connect 10 accelerometers to your board, and you want to do it by using just the two cables of the I2C, what you can do is you can change the address of the slave. So in this case, there is a software address that you have to write. And then all these slaves can coexist on one unique bus line, and they can all be connected to the master, one per time, of course, in reading or sending, but still all connected to the master. So in this slide, you can see here the way that this works with the Arduino or some self-made boards that you have to connect just SDA and SCL, and of course the ground. When the circuit becomes rather big, or the lines are quite long, or you have some noise, what you can do is you can pull up SDA and SCL. You can do this usually with 4.7K resistors. And because this is pull up, they should go to the VCC, VDD, or the 5 volts in the case of the Arduino. And here you have these two connected to the lines. So let's have a look to the code. Also in the lecture from Neil is mentioned the wire library. With the two microcontrollers. So here there are two codes actually. So again, it's very similar to the rest. You have here include wire and then wire.begin. So that in case you have multiple masters, it's mandatory to define an address, because every master must be identified in a different way. If you don't specify any address in the wire.begin, then you are the master and the only master in the whole connection. And then the way that this works is rather easy. You have to, let me bring this to the, you have to start the transmission. Every time you start the transmission from the master, you have to specify the address of the slave. So in this case, you don't have the SS or cable select pin. You need just to write a number, and this number must correspond to the slave that you want to write to. And then you use write that just prints the bytes that you would like to send. So this string, for example, that is made of 5 characters, 5 bytes, and then just a byte, which is a number over here. And then at the end, you do end transmission. So this code, it's rather simple to do. There is also an implementation of this in software. So for the, again, maybe if this was not clear, for the I2C, for the SPI, for the serial, you should have a hardware that supports this protocol inside the chip. It's written in the feature list of the datasheet of this. If you don't have this hardware port for I2C, SPI, or serial, you can still do it in software. Of course, eating memory or going to the low level as Neil is doing. So there is also the way of doing the I2C using C directly, for example, without going to a library and so on. So the other code is the code of the slave. Over here, array order bring to front. So the slave just starts the communication. In this case, it specifies an address here, 8. So it's the same that the master is sending data to. And then what they implemented is they create a sort of on-receive hookup. So this on-receive is something that will be executed every time, similar to the SPI we saw before, with the interrupt. Every time that you receive something from the I2C, this function will be executed. So here you have this function, receive event, that is inside this on-receive library call. And then inside here you have basically the y.available, which is similar to the serial.available. If there is more than 1 byte, we read it, and then we print the character over here. Yeah, and then we receive the other bytes here, and then we print the other byte over here. So, and then we print as character in this one and as integer in this one. Remember that the character were the first ones that we were sending. X is characters, and then the last one here, range or the range to front, is just the number that we have sent. So basically here we just use y.read and y.available to check if there is something and to read the data. Take care that in this case reads only 1 byte per time. Okay. William, questions about this code or protocol?
Can you bring the other text box over so we can see them both at the same time, please?
Sure.
So in the sending one, we have our, hang on, sending's on the right now. So we're sending, we write X space is space. So we have 5 bytes going out. And then we're writing X, and we're only writing a 1 byte because we set it as a byte, I see, okay. So we set the value, the type of character of X, we had to set that as a byte. So that's not an integer, but rather a single byte, which is a number between 0 and 8.
255, yeah, or 254.
Oh, 255. Yeah. Okay, right.
Yeah.
All right. So it's okay.
It can also be 1 character, but yeah, in this case, it's numerical representation.
Between 0 and 255. Okay, all right. Yeah. And then, so when we that much, I think I get that, and guys, do you guys understand that part? Because I'm okay with that bit. The piece that I now questioning is I say wire.begin transmission 8, And that's sending to device number 8, and that number 8 is the same number that I use in the setup of the receiving device on the left.
Ah, yeah, here, yes, correct. It's the ID.
Yeah, so that's, and so if in my device I had wire begin space or parenthesis 7 and parenthesis, then it wouldn't react to this message at all.
Sure. It will look for 5 ID 8.
Okay. And so when I have my begin, so in the libraries, buried somewhere in the libraries is what to do with begin and end transmission. But are those what are we calling handshake elements?
The handshake is hidden inside the begin transmission.
Okay.
Yes, it's some kind of handshake for the specific slave. So every protocol has a different handshake. You might know the handshake. No, it's a sequence that you need to execute to start communication, to establish communication. No?
And then this end transmission we have to include here, we have to actually put an end on it. We can't just, it doesn't automatically put that there.
Yes, maybe this is something different from, so in serial, you can also do that, but it's often we don't do.
Just don't.
Yes,
yeah,
we just don't. But in this case, think about a slave. So you have 100 slaves. Every time you want to talk to a new slave, you need to close the connection with the previous slave.
Okay, so that makes sense. Now in the other loop, in the receiver loop now, we're in the void receive event. So
yes, loop is empty. Loop just waits a little bit.
Okay, so now I get it. So the receive event that we had earlier where it said wire.onReceive, that's saying if something comes, so if on the onReceive do something, and the something we're doing is in the parentheses, and that's the receive event function that's down below here.
Correct. You can put any other functions you want. It's not receive event, is I2C
Just
event.
a name. Yeah, that's fine.
It's a link to a block of code that you want to execute whenever
something comes on the wire. Okay, got it. And then, so it essentially we can read that line, that third line of the setup, or is just saying, if you receive something on port wire, do receive event.
Perfect.
Okay. Why do you have integer how many in the declaration of your receive event?
Because this one it can.
Because you don't use it.
Yes, you could have some parameters that have been being passed from the onReceive that will tell you, for example, how many bytes have been sent. So you can use that, let's say, as.
So instead of a while loop, I could use a for loop with a limit of how many?
Example, yes, of course. Yeah. So this is automatically done by the library. It passes you automatically the number of bytes that you have available. You can also do that in the serial usually, but usually, sorry, we don't do it. We just do if there is something available, just read it. It's like the same. That is done.
So this code in your while loop, what you're doing is you're reading one character, passing that out, go to the next character, pass that out, go to the next character, pass that out, right? So you're reading bytes one at a time.
Yes, but have you understood the condition, William?
Yeah.
The condition of the while. Have you understood the condition of the while?
Yeah, I get the condition. That's fine. That one is less than wire available. Yeah, I understand that, and also understand that means that it's going to loop out before the last byte. That's fine.
Perfect.
But why are we doing it with a while loop and not a for loop?
It's up to us. We can also do it with the for and count how many. Make a counter until see. It's up to us to implement this.
Is there an advantage one way or the other?
Well, I think it's just for convenience that you wanted to save the last byte. You can do a for and then iterate for how many minus 1.
Yeah.
So you could keep the last one out. It's up to you, the implementation. There is not a specific reason,
Okay. One isn't better than the other.
Actually, this one that uses wire.available, it also takes into consideration the fact that more bytes can come into the buffer. But you have to take care that this, so every time that there is a complete data received, let's say package or bytes and so on, this one will be executed, So then it's always working here. Also the for is always working, but this one checks the buffer every time, let's say. just is more, let's say, maybe real time than the 4, because the 4, you know, just you have the how many. This one checks in real time the buffer, how many bytes you have in the buffer.
But would I want to use, if I had a device down the line, so I used to have NMEA machines on my boat. Now they worked with something very similar. And they sent a string of defined length. And so with that one, in order not to have a garbled message at the other end, for example, when extra bytes or whatever else it is comes onto the string, then I would use a for loop knowing that I had a fixed length sentence, and then anything else is garbage.
So you
and
got
then I
the
can
point,
wait for the next handshake.
Yes, you got to the point that these protocols are really low level, basic, simple, in a way that the data that you can transmit is just generic data. So on top of that, you can implement your own language or protocol, you know, or high level protocol.
Okay.
So, you know, when I was working to work with the APIs of Facebook a long time ago, you have JSON data. The JSON data is separated by the parentheses, you know, and so on. So you use this parentheses to delimit. This is a field. This is description. This is the caption. Or even with the serial, you know, you could have always the transmission of 2 bytes. The first byte is the node ID, and the second byte is the payload, which means the content that you want to execute. Then inside the payload, you could have all ontology of data. You know, it's up to you. So you can have delimiters. So if you have delimiters, you can send variable data length. So until you reach the delimiter, you go to the next one. No?
Yeah.
Then with a fixed size, it's like you are coming to the concept of packets. So every packet can contain a fixed amount of data, you know. If you want to send more data than a packet can contain, you need to split this in more packets. But then you have pros and cons, of course, because you can then have the redundance control check, CSC and blah, blah, and so on that packet to check with the TCP/IP that the data is correct. It's long discussion with this. Okay, what else do we need to check, William? Or Hannes, Ferdi, or?
I'm good.
Okay. So I think Wi-Fi is also one of the most common modules that you could use. But like going from I2C or SPI or serial to the Wi-Fi is like making a huge jump, because underneath the Wi-Fi we use the Internet Protocol, and on top of the Internet Protocol we use sockets. And in the specific case of the ESP8266, we use the HTTP protocol. So the HTTP, guys, protocol is the standard protocol that you use to interact with the World Wide Web, so the websites and so on. It's also used by default from a lot of application programming interface. So if you want to read some open data, you know, from a database, or if you want to interact with social media, if you want to interact with WhatsApp or Telegram and so on, they all expose what we call application programming interface, like open channels that you can use to send or read data from. So the HTTP protocol is built on the IP protocol and is the one that we can use with a Wi-Fi model. So the Wi-Fi model, as I told you, uses the Internet Protocol. So the HTTP protocol can be used, but also UDP. So something that is not TCP/IP, but it's UDP or other socket protocols can be used. In this case, in this example, is HTTP. Sorry about the contortion of the words. I believe that all of you are a little bit familiar with the IP addresses. Neil was talking about them. Now we completely, let's say, surpassed the number of IPv4. So he was talking about IPv4, that is 32-bit number. And then we are going towards the IPv6, where we can have billion devices connected together. So going back to the Wi-Fi is a wireless communication, is defined by the 82.11 standards, the Wi-Fi Alliance and so on. Along the years, there have been a lot of different standards. I remember a long time ago there was the 802.11b, that was just 11 megabits. Then there was the 802.11g, that was 54 megabits. Now we have N, which is under 50 and 300 megabits, and the newest ones are even faster than that. Usually this radio works at 2.4 gigahertz. The newest ones, they work at around 5 gigahertz. So they have higher data rates, a higher range, and so on. So going back down to Earth, this is how Wi-Fi.
Daniele, can you hear us? We can't hear you anymore.
Just in time for me to finish my coffee.
It's a bit, it sounds like, or looks like irony to me that talking about Wi-Fi, obviously his connection broke down again.
Yeah. I think anytime you start talking about telecom, you're talking about irony.
Yeah. Yeah, even the color logo is a bit ironic to me.
Well, when you start realizing what's going on here, coming and going, man.
Sorry,
we don't know whether you're coming or going.
It's a joke made on purpose. Lecture networking, it cannot work.
That's okay.
Sorry.
It's all about staying humble, man.
I will try one more time. If this doesn't work, I will use my data from my phone to tell you to postpone the lecture to tomorrow.
Okay, sounds good. So we have a funny looking antenna here. Is this the Wi-Fi style antenna?
Well, it's just the PCB style antenna, let's say. It's a simple antenna. This model, the more, let's say, a professional one, they come with a connector if you want, so you can connect an external antenna, because this one is not going to reach much far away. I think in the lab where I tried in my Fabacademy, this antenna was maximum around 20 meters or something like that. So let's go back to the discussion that to implement the Wi-Fi, you need a very powerful microcontroller. And these microcontrollers are now becoming a standalone microcontroller. So this Wi-Fi module that we use, it's almost, let's say, obsolete. It's good to make some tests, it's still mentioned and so on, and also in Fabacademy. But the newest one, the SP32, is much better than this because it has both the network on board, so Wi-Fi, even Bluetooth, and it's having also flash memory and GPIO pins as a normal microcontroller. So you can have it as only one solution, let's say. So this device...
Does a machine like that remember to call your mother on Mother's Day?
Sorry? Remember to call?
Does it have a reminder to call your mother on Mother's Day?
Well, you can make one. Could be a nice project.
Yeah, so 3 more days. I'll give you a call.
Guys, this device, they talk to internet because they use the internet protocol. So through your router, these devices can talk to a server, and then once the data is in the cloud, you can do all kind of crazy stuff. You know, you can send a push notification to your phone. You can activate a model in, I don't know, Japan or whatever through IoT. So this device can directly talk to internet. As an exercise to work with this device, you need to practice serial, because the way that you can interact with the Wi-Fi module is through serial. So the Wi-Fi module will give you Wi-Fi connection, but to talk to the Wi-Fi module to configure it, you need to use the serial communication. So in this simple schema, you can see a little bit how it's connected. Use TX and RX from the Arduino to connect to talk to it, and you give power to it. In this case, this module works at 3.3 volts, and then you just have the ground connected to it. So you need these cables. Watch out, because this device, when you transmit with low signal or with certain baud rate, data rate, sorry, and so on, it can take a lot of current. I think Neil was mentioning this for some modules. So this can take up to 2 ampere current. So this means your poor Arduino that can give you 40 milliamps, or the voltage regulator that is here to give you 3.3 can easily like be damaged. So therefore, it's also recommended that when you put it in serious operation or inside your project, you give power to this separately. For doing some tests, it's fine to just use this communication.
And by giving it power, you mean use this thing? Or do I need to use a separate voltmeter?
You should use a 3.3 power source.
And is that what this is on the Arduino, this thing?
Yes, but this comes from the USB. It's not very powerful.
No, this thing right here is an input, right? I put a transformer into this part of it.
If you you can put a transformer there. If you put a transformer there, you could have more current. But I don't remember the current of the voltage regulator of the Arduino. I think it's not much. I recommend you to give external power. So you do some tests like this, and then you will give external power. With the battery and a voltage regulator should work. I will show you some examples from my Fabacademy.
Can we set fire to our Arduino this way?
Sure.
Excellent. Cool. You all heard him. He said we could set fire to it.
There is an example later on we can do live. This is just a small code that we can look briefly. Let me just increase the size a lot. So, okay, I told you that we have to interact with this module through serial. So the only communication channel that will open is the serial communication. Also, I don't know, William, maybe from your age, there must be some old ways of communicating with modems. Like old dial-up modems and so on, where the then is not much. Just for some quick testing is fine, but then for configuration maybe, but then need more current. Thank you.
Got to be the power.
So the module itself uses a kind of special commands. They're called AT commands. The IT commands are like very answered commands that you use to communicate with modems, to configure them, to talk to them, to send data, to receive data, and so on. And also here you need to use the AT commands. So for the ASP266, we will see the specification. You have a set of specific AT commands. And these AT commands will be sent as strings to the serial port. So let's have a look to the code. At the beginning, we define some strings here. So this this string over here is how you could do a HTTP GET call. So it's actually one of the functions that you can use of the HTTP protocol. And this AT plus CP send is just one of the AT commands that you can use. In this case, AT plus CP sends, if I am not mistaken, is the payload that you can send. So what you do here, guys, is you start working with the serial, and then you start the serial, then you start sending some data. So in this case, AT plus CV JAP connects to a network. So here you should put your network name, the SSID of your network name, okay, like the staff network from the offshore Randall, the Fabacademy network, and so on. And here you should put your password. And then inside the loop, what we do is we start a TCP protocol here to this IP address and to this port. So you remember, IP addresses are said they are like buildings, and then the port are like rooms inside the building. So every time you connect to a website, you use the port 80, for example. If you use Skype, there is another port for this communication that we have, and so on. And then here, what you do is you write this data to the ASP module, and then you wait that this answer you back, you read the data, and you write this data to the computer serial, and then you wait. So this one, guys, what it does is just does get HTTP call here, and then receives back the data. So get HTTP call can be, guys, anything. Can be, you know, opening google.com. If you do this, and instead of writing this IP address here, you write the IP address of Google on the port 80, or you write the host name of Google, www.http//column www.google.com. Then what will come back here in return is the HTML code from the web page from Google. Okay. So in this case, when you connect to the network, this depends to what is on the network. If you connect this to your router will automatically route the request to Google, for example. If you connect this to a local network, then this will connect, of course, to your local network. So if you have a small server, your local network, it will talk to that server over there. So the way that you talk with this model is just chaining the strings, and the content of the string are basically the protocol that you need to use. So in this case, the HTTP protocol is on top of the TCP protocol. And then, so you use first this one, and then you use the get request over here, and everything is chained in strings. Yeah. So first you send this one to start the TCP communication, and then you send get, and get this string get contains this string, sorry, over here to do the get request. So you can use this model in many different ways. This is just using it as a client. So in this case, client means that you connect to a server. But depends how you configure this model here, you can use it as an access point. So this means that another Wi-Fi device can connect to it. And if you use it as an access point, you can also expose a web server onto it. So, and then you can have your own small web page onto it. So inside the ESP8266, you can make like a super small web server. Of course, take care that the memory of the Arduino in this case is 32 kilobytes. So you cannot put much of HTML code inside, or images, of course, inside. There is a small example also. We can look at live after the slides. William, more questions or comments? Or Hannes?
Yeah.
Let's go.
So we have at the beginning of the code, okay, I get that there's a sentence. That's fine. And then if we go through the setup, we had to, yeah, so what do those two lines do? That's just getting the length of the get line.
Yeah, we put here, so we are chaining the get and ship send, if you read it.
Yeah.
So we are taking the ship send, sorry, it's this one on the bottom.
Yeah, and then it's the length. Yeah, okay.
So we put the length because the ship send we will see in the specification takes the number of bytes that you want to send. So this one is the payload that we want to send.
Yeah.
And then at the end we put this /r/n. So we chain these two. Okay, let's go on, William or Hannes or Ferdi.
Yeah, and then you have the ATCWJAP, which is the login, and then you're going to write that to the ESP serial. Where did you define ESP serial? Oh, .begin.
ESP serial is just software serial. It's just the software serial that communicates to the ESP.
And where did that object come from?
I think
it's not declared in this code, right?
It's just because I cropped the example a little bit smaller. But
Okay.
if you look in the reference for Wi-Fi,
okay, that's fine. We'll look that up later. So the ESP serial is some kind of command. All right, and then we write to that. Then we go in the loop. When we go into the loop, So the AT-CW-JAP logs us into the network, and now when we're in here, we're going to write that serial print statement. Why are we reading available? To see if there's anything there.
Yes, because we want to wait the answer from the ESP that we send that command. So to every AT command, you have an answer. So there is an answer. This answer is, in this case, something related to the command that you send. And at the end, there is OK. And this, it's something that you should expect like visually. So when you, I have actually here ASP8266 connected, maybe this helps a bit. So wait a moment. So this is like, I have here an example is in the example code, guys. If you send an AT command, so I'm sending this to the serial monitor. The serial monitor will send it to the Arduino, and the Arduino will send to the ISP and give me back the response. Okay, so if you send IT, you have OK over here. So if you send some other things, I don't know what I was sending before. Maybe let's have a look quickly to the specification of the module. I think there is a nice one from the CBA. This is from the CBA, from the guys from Neil, and there is here a quick reference. Yeah. So for example, this one lists the access points that you have available to connect to. So if you type this command into the serial monitor, you wait a few seconds, and this answers something, and at the end of the answer, you also have OK. So that way that we did in the code is to send the command and then to wait for an answer. So these are actually the Wi-Fi networks available here around. William, or guys, we can go back to the example of it.
Yep.
Yeah. So then we do the same, but this time with a zip send, which is that string that we made on top. This string over here. Sorry, William?
Why are we doing that?
So because this is the protocol based, the HTTP protocol. So we need to open a TCP connection over here, and then we need to send this HTTP/1.1/r host. This is part of the protocol. So if we read HTTP get request, and you look the content, so, oh, sorry. It's like this. You have get / something, then / HTTP/1.1, and then the payload over here, blah, blah. And so it's part of the protocol.
Okay.
Okay, then William, let's go on. Or guys, let's go on. We are here. Keep send.
So we do while available write at read.
So we wait 5 seconds.
What?
Yes, we wait 5 seconds, and then we read all the available answer. We wait 5 seconds because it could take some time to do the request, just to make sure that we have the data back. And then with this, we read the buffer of the serial that has been populated by the data coming back from the module, which is totally like this data that you can see here, like it's an answer. Okay, William, or guys?
Sort of. I guess I'll have to play with it to understand it.
Now we do an example so we can play it a little bit later. Then, so basically you send a set of strings to the module, and these strings are TCP protocol, HTTP protocol, blah, blah, and so on. And then what we do, we just wait that from the ESP serial comes some data, and then provide this to the computer so we can read it. It's actually the same that I'm doing here, but this is done in real time. Real time means that I'm sending it myself, so if I send something wrong, it says error and so on. And then that's it. We just do this for all the strings we have. So the first string that is not a variable, we just add it here. Start the TCP protocol, then the HTTP protocol, then the payload here. And then we wait for the answer. We wait 10 seconds and we do everything again. So this calls every time this IP address to this port, which HTTP gets protocol. So every 10 seconds, you have this HTTP gets done. So also for the ESP8266, there are libraries that will allow you to do this without writing by hand the protocol here. But it's good to see a little bit how the protocol works inside. Yeah. So actually the protocol itself is this one on the right, because this AT plus zip start is just the command itself. So if we go back to the here, I will look the start. So this is just a subset here. So this one starts a single connection. Here. Set up TCP or UDP connection. And this takes this parameter, this ID, and then you have single connection, multiple connection, and so on. Then it takes the IP address here, and then takes the port here. So this is the way that we call these APIs. Let's say we execute this AT command, which is AT plus 6 star 8080. Let's share. So what we have to do here is just to define the correct protocol strings, talk to the serial, read the answer, and that's it. There is nothing more than that. But of course, you need to understand which one is the correct syntax for the commands and for the protocol. So what I recommend you to do is to start from one of these examples and then read the specification of the commands and start playing with the commands. This is not exhaustive. This one from Dan Chen. I actually met this guy in Taiwan. This is a nice syntax, a nice, let's say, synthesis, sorry, of the commands, because the ones that are here are much more than that. Yeah. Yeah. Okay. So this was the Wi-Fi. I think we can do this test together. William, Hannes, more questions?
Not at the moment. I think I'll have a lot more questions once I
let the smoke out.
Yeah. Once I brought
So the Wi-Fi guys was very nice for my Fabacademy because in that case I made it an IoT system that was telling me like, okay, if somebody was in the room or not. So this was able to send data to a local server through a router. And this server was exposing a web page, and the web page had the rooms. So you could see in real time if a room has somebody inside or not. And these are the modules. I think after the slide, I will show you some Fabacademy examples about Wi-Fi. Okay, so other things about Wi-Fi, because it implements the IP protocol and the TCP and so on, it's not very fast. So you can have, of course, high baud rate, byte rate like 300 megabit and so on, but it's not very reactive. So think about like if you have to control something remotely, think about like a drone and so on. Before this establish the communication, start sending the data and so on, it's not really real time. Once you establish the communication, it's very fast in sending really a lot of data. But before that, to establish the communication and you know, to just pause and resume the communication, it's going to take time. So it's very good when you need to transmit data, but this data doesn't have to be changing fast, or you shouldn't have time constraints in your project. So it's not very good to control a drone, for example, with this. It's actually very slow with Wi-Fi. Okay, if there are no more questions about Bluetooth. So Bluetooth was a king of Denmark and Norway, I think. And the protocol was invented in Sweden, if I'm not wrong, and Nokia and Ericsson and so on, IBM were involved in it. It all started as a low-range protocol for mobile devices. So it was meant to be implemented on cell phones. It started like the first cell phone, I think from 99 or something, that had this protocol. And then this now has evolved and extended to many other devices. So with Bluetooth, you can communicate, you can do simple communications, but between two close-by devices. So they have to be in a range of meters. There are new technologies that can allow you to extend that, but so far this was the reason why it was invented. And there are nowadays different versions of that. I think we are now in the 4.0, which implements also a very nice low power feature. So they sacrificed a lot of speed in the communication just to have something that is low power. So there are some devices like the iBeacons or the or some keychains that can be powered for years, with a small battery. This can be maybe an interesting scenario for you as well. What is interesting is that it's not so complicated to communicate with a phone. So if you have one of these modules, of course, you can communicate between the modules itself, or with any other Bluetooth device. So you can easily have an application with the phone that you can send and receive data to your device. Think about like making a remote controller for your project that you can I don't know, change the settings through Bluetooth or something like that. So the model that we have in the Fab Lab are one of the most common ones. They were mentioned also yesterday in the lecture. They were the HC05 modules, which they implement the Bluetooth 2.1 with the ADR, which is the enhanced data rate. There are also some Bluetooth 4.0 modules, but in that case, the protocol changes completely. So you talk to people using serial again. So what you have to do is to just connect the module to the serial port to the Arduino and then just power the chip. And then it's rather similar to the Wi-Fi module. So they also take IT commands, and once they are set, what they do is everything that is being sent to them will be sent to the paired device. So once you establish the communication, or you set the communication with the settings, what you can do, can just throw data to the serial, and this data will be transmitted. And this is what is going to be done in this small example, because we have another example where I can show you the settings order, maybe to front. So what we do here, we just establish the serial communication, and we then print this data. Actually, in this case, we read, the data, and we, according to the data that we receive from the serial model, we put the LED on or off. So what is important to know is that this serial over here is not connected to the computer. It's connected to the monitor. Sorry, to the module over here. And then this module over here will receive the data from another module or another Bluetooth device and will send it here to your Arduino. So in this case, this is just like reading from the serial monitor. But you don't read from the serial monitor, you read from the Bluetooth network and the module itself. So this code is almost straightforward. I don't know if I have to explain it. It's just switching on and off an LED according to the data that you receive into the serial. In this case, the module is connected to the serial, so it comes from Bluetooth. Then in the next example, I will show you real time. It's going to be more complex, so you can see more things. Hannes Williams. This code?
This looks okay to me. It's just serial.
Yeah. Okay. So maybe let's go to the examples I prepared to you guys, so you can see more. Okay. So here there are the reference divided for protocols, and let's start to show you some brief examples, maybe. So there was Christian in 2018. So networking, guys, is not just using an existing protocol. You can invent your network. You know, you could have a photo transistor and a light, and start, you know, beeping the light to have your data sent to the receiver. You can use infrared, for example, communication. And this was something that, for example, Christian implemented. In this case, you just play with the code to read if the input is high or low, or the analog is specific value, and then you interpret this within your protocol. So you implement your network as you wish, basically. And here, Christian did some nice experimentation. You can read the whole story. But he was able to communicate by using the infrared. So it was just locating the board close to the other in a way that this matched the communication, then this was switching on by an LED. So you can play with that, guys, and you can make your own protocol. As far as I remember, he had some things to deal with. For example, how long this would take, some timings between the rules and so on. But then it was just made with digital write and digital read. Yeah. So here you can see more example of that, where he was playing with this communication system to switch on and off these LED strips. I recommend to have a look to Christian, guys, because he did a lot of nice experimentations with networking. There was another similar example from my colleague Enrico from 2015 that implemented a communication using still infrared. And what he wanted to do is that he can put like many nodes like this, and after a while they will converge and synchronize the blinking of this big LED according to the communication. So he wanted to make a sort of self-organizing network over here. And here you can see some sequences that he recorded and some experimentation that he did. Here the code is just, again, just having some delays and then digital write and so on, and digital read and some intervals and so on. And here there is a video about that. But my internet is not the best for now. These things were communicating and then synchronizing, almost synchronizing the two beeps, the two blinks over here. Okay, these were just two small examples. Let's go to the examples I prepared for you guys over recent. Let's start maybe with the. Are you guys fine with serial? I also prepared some serial and I2C example, but if you tell me you're fine, we go directly to Bluetooth and Wi-Fi.
I think we can probably figure them out. Go for the fun ones. Okay,
so we go to the Bluetooth maybe. Also, I had another one that was not in the slides, which is the radio NRF24. So let's try to look the code for the Bluetooth. Sketchbook.
So the kind of board we'd need to do this would be an HC05, HC06 Bluetooth thing, or what?
These modules have the same behavior. They take the same AT commands. So this example works with both with the HC05 and HC06. There are slightly some differences between those.
Okay, but either one of those would be fine. I'm just looking online to get one so that I can have some stuff here to play with.
You can find it everywhere. This example is HC05 because these are the ones I had at home.
HC05.
Some in the Fab Lab. I can bring one or two for you tomorrow when I go there to fetch stuff.
Are there any in the Fab Lab of those little modules or not?
There should be some of this one. I think, Freddy, you might have them in your drawer, maybe? Or it's back to the lab?
Yeah, I'll go and have a quick look, okay?
Yeah.
Awesome.
Otherwise, I'll just buy some, and then they're not that expensive.
Okay, so here is the example. It's a little bit more complete than the one in the slides. So we have a master and slave in this case. This is just, let's say, a convenience. Because one will send the data, the other one will just receive it. So can you read the text, guys, or is it too small?
That's good.
Fine.
So in this case, what we have here is just the software serial and the serial. Why we need two serial? Again, because one serial will communicate to the computer.
Yeah.
The other serial will communicate with the module itself.
Yeah.
So what we do here is when we have something available. Oh, sorry, I think I confused the name. Let me change the code quickly because this one I confused the names. Yeah, okay.
And that's as quickly as can be changed from being a slave to a master. The revolution has started.
You know, also because this device can be both slave and master. So here we do actually the same thing. It doesn't change anything. So just what changes is that here we read data from the serial port, and then we send this data through the software serial port. So the hardware serial port is connected to the computer. The software serial port is connected to the module. So it's just a serial relay, let's say. What we receive, we send.
All right.
And the slave is actually the same. The slave, it just reads from the serial, software serial, and send this to the hardware serial so that we can read the message. So those are just serial relays. So what we receive, we send back. That's it. So what makes the difference here is this test code. So this test code over here is also a serial relay, but in this case, the serial relay takes the commands from the serial monitor. So what we do here is we use this to configure the module before starting the connection. And how we configure the module? So there is here an example with some similar codes and some AT commands. And this is exactly the same that we use to configure them. So here you can see the AT commands that we need to send. So when you send AT, this returns OK. And this means that the communication is working. Then you send the name to the module. So the module will be called HC05 slave. Then you set the baud rate of the serial communication. Then you set the role of this. And the role can be something that listens for connections or something that connects to. And then with this, you get the address of the module, which is a MAC address. I think Neil was mentioning this. It's hardware address. And then what you do with the master is rather similar. You set the name, you set the baud rate, you set the role as a device that can connect to another device. And then you say, please connect to this MAC address. And this MAC address is the same as this module over here. So this is the pre-configuration that we did before. And then once I connect the two Arduinos, so once you upload this data to the module are configured to be slave or master. And then once I connect the Arduino, let's see if this works in real time, but I have to change the serial port. So let's see, I have two Arduinos here. I don't know if this is the master or the slave. So
You can tell by the one that has the whip.
Yeah, so this one is slave because it doesn't do anything with this. So master and mother. Okay. So enter commands. So if I send something here, this will be sent to the other serial, to the other module, and the other module will send me back the same as answer. So if I do test here, that test. So this has been sent between the two Arduinos. Now testing the code, and it's the Bluetooth communication. So the easy part of the Bluetooth communication, especially the 2.1, is that it is all based on serial, and also the configuration is done apart. So you can quickly configure your module with some commands beforehand by hand, okay, and then you can directly test the communication. Okay, if you like, we can do the configuration together. So this is the code for the configuration. I will just upload it. Neil also mentioned that these modules have dual state. One state is communication, one state is configuration. So as I explained in the example, when you want to configure the, let me check the example, which is also written here. When you want to configure the model, okay, you also need to configure the key. You need to connect the key pin. So whenever you connect the key pin and you send high or low to this one, the model knows, okay, I'm in the configuration mode. Okay, so I can take the T commands. Otherwise, if I'm not like this, I will just send the serial data that I will receive to the other device. For that, I need to take a cable. And this is non-fino. So I need to connect the key. Okay. To, in this case, 3.3 volts. So I have to give logic high to this pin. I will just disconnect the Arduino and upload the test code, which is just a relay over here, and then we upload the code. I need to select the component.
Error.
Okay, so now I'm here, and a T command. So if I press AT here, I can have, okay, so if I want to know the module, the name, I do a T minus name, like this, or I think I forgot how to do it. Let's take it from here.
AT plus.
Yeah, plus, sorry.
Is this the right module?
Sorry, Fabio?
Is this is the HC05, no?
Yeah, one moment. Yes, HC05, I confirm it.
Yeah, we have 9 of those.
Yeah, perfect.
Hannes, could you pick up 2 of them for me, please?
Yes, sure.
Thank you.
Are you there tomorrow at 8?
I'll be here all day tomorrow, yeah.
Yeah, I'll be here.
Okay, awesome.
Okay, let's reboot, because with that at T minus name, I think the module had some issues.
But
Yeah.
those modules won't be of much use without the according adapter board, no?
Ah, Fabio, the mines that have the adapter board, those haven't?
No, they're just
Adapter
like this.
board. Adapter board, we just need the string, the cables, right? What adapter board?
No, really. It's more than that. There are not with the adapter board, Fabio? Okay.
What adapter board is that?
Let me stop sharing, maybe. Maybe there must be some wrong ordering. Can you see my camera, guys?
Yes.
Yeah.
There is an adapter board, you see?
Yeah, your background is blurry, so we can't see.
So you've got a...
Yeah.
Just have, it's just the adapter board you're saying is just the pin header, isn't it?
Not really, because there is a voltage regulator on it, LED, more stuff. I think I will try to procure the adapter board. So we can
I think we had 2 with an adapter board, and I gave them to Jefferson.
I see.
But the remaining 9 ones don't have any adapters. But I could mill a few. We just have to solder them, no? And we need the voltage regulator, I guess.
It's also possible, yes. I can look the schematic of this one, Freddy, and give to you, or we can look the schematic of this one.
Yeah.
There is not much, just a LED couple of resistors and voltage regulator. Yeah. Okay, let's go back. Thank you, Ferdi. Let's go back to the IT commands. Let's see. Let's take the but this crashes if I send like this. Where are you? Here. So, okay. Let me look the it should return the name. Let's see if it return the address. It somehow crashes. I think I have to bring back to original. Give me a moment. Let's see. So these models, guys, that have their own controller on board, you need to, if they don't work, let's see, you need to reboot them. Let's see, T plus the one before. Let me try with this one. Let me check if the connection is correct. Where did I put it? Here. So the key must be connected to 3.3. Yeah, which is close to 5 volts. Okay, let's try once more. Let's select the proper COM port. And that. So let's see. No answer from this one. Let me quickly grab another model, guys.
It's more fun when you get to let the smoke out yourself.
Yeah, I had the chance to do that last week, at least blow off some steam. Remember the blue flow tunnel pump in your lab? I moved it about 1 meter to the other side of the pillar.
Ooh.
Didn't fit through the pillar and the wall, so it had to get on top of the flow tunnel inlet, from there on top of the dark room, and then down the other side again.
Yow. Okay.
2 people stay, and nothing broke. No one got hurt.
And why did I want to know that? I don't think I wanted to know that. Excellent. How much paint did you leave on the walls?
Not much.
Good. Cool. So is it watertight now?
It's still a lot of work. Those 300 millimeter diameter pipes are a pain in the behind to move into each other, and also if you want to detach them again, it's impossible. So I'll be working on it this weekend again.
Okay, cool. Thanks.
So guys, let's send exactly these commands in case I'm making some other mistake that I don't.
So we'll know if it works if we see smoke go past your face mask, right?
Yeah, but in that case, I think it would be better to have OK. I know what's the reason. Sorry guys, I'm super stupid. Is this new line at the end here?
Okay, you're looking at the new line. We don't see it.
Sorry. I think share screen. You know, when you send data to the serial monitor, can you see my guys?
Now we do. It says enter AT commands OK.
Yeah, you can select here what will be at the end of the line that you send. You can have no line ending. You can have new line /n is new line. You can have carriage return, which is enter /r, or you can have both new line and carriage return. So in this case, because this is just a serial relay, so what it gets, it sends to the module. The module doesn't take both NL and CR. It likes only /n. So you have to select a new line. So I have to reboot the Arduino and then reopen the serial monitor. Reboot again. Let's see. Enter T commands. Yeah, okay. So let's see if this works. And of course, doesn't work. Wait a moment. But I remember that that was the mistake I did when I tried. Let's see. Okay, there is an OK is good. There is another OK is good. There is a third OK is good. Okay, good. So T plus name. Now we get the name. Good. That was so this, for example, is a query. So we ask for something. Then if you change like this, I don't know, you call it slave. You start setting some parameters of the module. At T plus name, it's slave, for example. That's okay. And then if you ask the name again, this will be slave over here. So the configuration, we can go back to the example, is rather easy. This again has the list of the commands, AT commands, and so on. It's available. And this one is just like a simple way of configuring it. So we give the name as slave. We set the communication with the serial of 9600 because by default is 38,000. And then the role that can be 01 according if you want to listen or to send something. And then you have the address over here. So if you repeat this command over here, then you have all the data. So you can do AT plus UART. And then here you're going to have as receive the current baud rate that you have set the module to. So if you do this again, and then you set the baud rate to 9600, and then you set the buffer and the parity over here, and then you ask again for the baud rate, then you have changed the baud rate. The baud rate of these modules, thank God, is not changing in real time. So once you set it to the next reboot, it will be applied, especially for communication mode. So when you don't have the key pin connected. Yeah, so if you want to get the address, you do a T plus add, and this gives you the address. This address is, the MAC address is unique for each device. And then you have to put this in the bin of the other module to connect to it. So then you can set the role, T plus role equal to 0. So this is a module that receives the data. And then you have the role 0 over here and so on. Okay, guys, I think this one shows you a little bit how you can interact with a Bluetooth module yourself. So this configuration will be saved. So if I now reboot the the model, I reboot the power and the Arduino itself is connected and connected again. This data is saved into the EEPROM of this module, so it will be there. So the name was slave. So if I ask ft plus name here, I have slave as a name. Yeah. Okay, guys, questions?
I'm good.
So the code again, it's rather easy. It just probably sending some data about it. Okay.
Yeah, unfortunately, I still haven't found a layout for the adapter board or for the breakout board.
So I just bought 2 of them online, so I'm all right.
I will look after the lecture maybe if I and try to figure it out. Yeah.
Okay.
Okay, guys, that was the Bluetooth. Example, I'll share again the screen. If you have then comments about the code, please, guys, just write a line on Skype. But it's rather just serial, software serial and serial. That's it. And then AT commands. Okay, let's go to the other examples. So we have here open recent. So we have here also the radio example I prepared for you. So example sketchbook. Transmitter. So then we close a bit of Windows. So I have the transmitter open. I will open the receiver. Open recent receiver here. Okay. So this model, I haven't talked about it. It's super common model. We should also have this in the Fab Lab. The NRF24 is from Nordic Semiconductor. You can buy it for really cheap price. There exist 2 variants, one with the integrated antenna, one with the external antenna. I bought this when I was in Shenzhen a couple of years ago. They claim that can reach 1.1 kilometer with the antenna, but I don't know. I don't really believe it. The difference between these and Wi-Fi and Bluetooth and so on is that this one is a proprietary radio protocol from Nordic Semiconductors. So this means that you have to use the specific APIs of the module, and this is something different from the other protocols that we've been using. Also, this one is quite real-time. Quite real-time means that it's really fast in sending and receiving data. So it can be used for remotely controlling a drone, for example. Many Chinese drones, like the one that you can buy for 15 euros or something like that, they have this chip inside to implement the transmission, the receiving of the data from the radio controller, let's say, from the joypad. So it's quite suitable for this kind of project. This device here talks through SPI, and also there are libraries to use it. So we should have some of this in the lab, if I'm not wrong. And here is the code. So on the left side, we have the transmitter. On the right side, we have the receiver. So we have to import the SPI library, as I told you. And then we have this F24 library, which is also linked over here in GitHub. It's just a library that simplifies the communication within the model itself. And then on the code, what we do is we need to initialize the connection. So here we have, of course, connected MISO MOSI. So in this case, it's the SPI communication. And then we have to select also the pin number 11. And then we have here the a status pin, CE. And then CSN and CE are here inside the call from the library to initialize the radio. Then here we have an address in hexadecimal code. And then you can change this address to the address that you want to connect to. And then it's easy. You have just this radio begin over here, radio.opening writing pipe with the address. and then our transmitter is initialized. And then inside here, guys, we just write our data. In this case, this write, it's a little bit different from the write that we saw in the serial or in the I2C and so on, because this one takes also the sides of the data. So here, the first parameter is the data that you want to send. The second parameter is the size of the data. In this case, this is a way of passing an array. Why I have commented this, I don't know. Yeah, sorry, it's here. So text is just an array of character. Hello world is just a string. So I pass here the address of this array here, sorry. And then here I pass the size of the array. So if you look more into C, you can see the asterisk and the ampersand operator. So these things are relative to pointers. And actually, an array can be used as a pointer. So you can point to the address, the beginning of the address of the array. Whatever. And then we write this one here every alpha second. So basically, we write this hello world every alpha second. Then on the receiver side, it's rather similar. We have the same connection. We have the initialization of the radio over here. We have an empty array, char array. And then in the setup, we begin our radio communication. We open a reading pipe. So we want to receive data. And we pass here the pipe. And then here we have, if radio is available, then just read the data and then print it after here. And this is exactly the same that we have done here. So with this, I don't know if my example will work in real time. I will try to see. And in case if we don't have these models, I think we can easily buy them because they are super cheap. I think they are in a range of €2 each or something. But maybe Fabby can confirm if you have these models later on. Kamp-5, Kamp-9 here. Let's see. I don't know if I'm the one that is sending or the one. Ah, yeah, it's something here. So these two are very close right now. I don't know. I can go far away from here and somewhere outside and see if this still works. But so this is the example code. So here is the connection with the module, with the SPI, and then this cable select and this extra pin, and that's it.
Did you say we have some of these units in the lab?
We might have some. Freddy maybe can confirm. They can also look different, Freddy. This is one kind with the antenna. Well, we might have the one without antenna. You are muted.
Do they come as pairs with both ends, or do we just have one end?
This one, Freddy, this one.
Yeah. So we have two of those three. And then we have a whole bunch of those.
This might be the same, but in another package from maybe other Fruitospark fan or other brands. I don't know. Maybe we can check those. They should be.
Yeah, there's lots of those here.
Yeah, but I cannot read anything from here. If you can type, or we can look the module itself. So guys, when you design a board for these modules, you should try to design a way that you can plug and play these modules. Like you have a connector for them, so that you can attach them to your board, as they are nicely integrated inside your board. You should expose RX, or if you want to expose the SPI for these modules and so on. I think there is the Wi-Fi example.
Ferdi, how much we need more? I have 3 from this left. I think it's the same like you have.
Yeah.
Then we have 6, and then I have 2, and then we are ready for all with the same ones, I think. If you have 3 of them, I have 3 of them for you. Then we have 8. I have 2 for me and for the rest. And then we have for all 2.
Okay, perfect.
Okay.
Yeah.
Maybe the red ones are also good, but I don't know the model itself.
Yeah, it's like impossible to read. Like I need more light and binoculars or something.
Oh, maybe I can.
Yeah, there's nothing really written on it. Like there's you can read SparkFun.
SparkFun?
It's from SparkFun, but like I would have to read what's written on the chip, which is probably easier by camera than by.
Rafael, this one that you can see on the screen.
Which one? I don't see your screen.
Really?
No.
Okay, it's sharing. Wait a second. Start sharing. Can you see the screen, guys?
Yeah, everybody but me.
Yes.
I see. Okay. Okay, I will send the link.
Yeah.
Okay. But looks like it's this one. Let me send you the link, maybe.
Mm-hmm. Yeah, this looks a lot like it. Yeah, I think it's the same.
Yeah, so this is then NRF from SparkFun. It's just another package, but the connections, they look the same. So they should work.
Yeah.
How many we have of these?
Oh, that's quite a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, so these guys can work as well as the one that I show you in the example.
And where's the antenna on these SparkFun ones?
I think it's the same as the one that Gerard has. It's here. It's
just
PCB.
a tiny in the PCB. Okay.
It's the PCB. Yeah. If you want, guys, I will not use these ones I have here. I can bring them to the Fab Lab, and you can use this with the antennas.
I'd like to have a long one just to try it because I'm going to build this into the roboboat. We've got everything together now for it. So if we've got some that have got some longer antennas, that would be great.
I think for you it's rather appropriate if you want to have some real-time control fast. It's very good for this. But look, I think I can give you mine. That's no problem. I will not use them. But anyway, it's €2 model.
Yeah, €2 plus 25 euros worth of tax to get it into the country. They're in Shenzhen, these things.
But come on, I think we can find it easily. Let's look together, maybe.
Need to find a European Deutsche Händler, but that doesn't mean it's here.
This one looks like here. Yeah. But it's the one without antenna. 2 pieces for €.
Yeah, I'll look at it.
Look, this one. Look, this one is with antenna for €1 per module. And it's yes, it's in Germany.
Okay.
You can. I think it's. But I can give you mine. That's no problem. Yeah. Okay, guys. This was the radio module that you can also try yourself. And then the Wi-Fi. I have prepared for you just a test for the T commands that you can use to connect to your router. It's also in the examples. Wi-Fi test.
Can you share the screen?
Yes, sorry. Should be coming. Gerard, it's called Wi-Fi test. It's on the link.
No, I'm wrong. I had only this
Right.
Funkteile. I didn't have the Wi-Fi ones.
I see. Okay, so you have the radio ones.
Yes.
Yeah. Okay. So what we do here, guys, it's always the same. We have just a serial relay. So what we send into the serial module is going to be sent to the module. And what the module is sending back is coming back to us. So this is just to test the RT commands. But with this, you can, try to connect to your Wi-Fi access point and download Google, for example, with these commands, So you can go to the serial module here. Let me change the port. That was correct. I have still the other Arduino connected, sorry. Oh man, too many COM ports. See if this one. Yeah, okay. So thank God here there is a nice writing that tells you put new line in carriage return. Yeah, on the serial model. So and this is the model here. Yeah. So if you go back to the list of the comments that is here on the link of the slides. Yeah, we can start playing with that. So let's have a look quickly to this command. So with this you restart the module. With this one you set the Wi-Fi mode. So you can be standby, you can be access point. So this means you accept connection from the others, so the others can connect to you, or both. Then here you have the SSID and password. So here you have the name of the network and the password, and with this command, @t plus cwjap, you connect to your network. With this, you list the network that you have. With this, you disconnect from the network, from the current connection. So you disconnect from the router you connected before here. With this one, you set the parameters of your access point. So this means if you act as an access point, you can put your SSID, your password channel, the Wi-Fi channel, add encryption. With this, you see the status of your module, if it's connected, disconnected, and with this you start a connection, TCP or UDP. With chip send, you send the data, so you send the payload, so the strings we were looking before, and with chip close, you close the connection to the access point. Yeah, with this you get the IP address. With this you set multiple connections. This you set as a server, so you open a port to receive a connection, and with this you see the received data. So I think we can play a little bit with these commands very easily. For example, let's try to make access point that I can see with my computer. For example, so I can go to the here. I go here. So also for this module, guys, there are libraries that can do this automatically, but it's nice to see a little bit of interaction on the low level with the protocol. So RT should answer OK. It's already OK. So we can put the Wi-Fi mode. So we can do IP plus CW mode, and then equal, and then mode. We can use AP, for example, so mode 2. Okay, and this answer OK. Then we can use this one to set the password and the encryption and everything. So we need to have here encryption, channel password, and an SSID. Let's try to do it. So I will put this one here. So the SSID, I will call it test the network. Password, I will give 1234. Just for test, maybe let's make it more than 8 characters. No. Channel, so this is the Wi-Fi channel. I think should be one common one should be 11, and then the encryption. This I don't remember how to set it. Let's try to do it like this without encryption and see what it does. It says error. So, sorry?
Don't lock yourself out of your network now.
I will, yeah, parameter description. So here is more clear. 0 is open. Let's make open network for now.
Oh, you security beast, you.
Then, okay, why I have the password? But let's try to do like this, error. So let's see what the channel is for this. Oh, look here, there is an example already made. Let's try this one. Then change this one. Because it wants the quotes here. It wants the quote.
Because it's a string, not a number. Yeah.
String is not a number, and so on. Okay. So okay, I just set this one just for test. Maybe just change this one to test. Yeah, and now says it's okay. Okay, now if I open my networks here,
Anybody wants free network, quick, go to Daniela's.
I should see this this network available. Test, it's here. It's also secure.
And it's secured too. Look at that.
Yeah, okay.
Very
so
good.
I will not connect to it because otherwise I will
You'll go bye-bye.
From you. Yes, guys. So, but just to show you a little bit how you could do that, I think we can even try to get Google, but I need to connect and put the password of my Wi-Fi network here. So I think it will not be safe. But in case to get Google, guys, you can just look the examples over here because it will be the same GET request that we have seen in the Wi-Fi example over here. So you can just use this code from the link, and then instead of host putting here this IP address and here the TCP connection to this IP address, you put Google. So when you put, when you go to website, you always connect to the port 80 by default. When you want to connect to something different, usually you type the IP address and then you type here the port. So you use column and then you put like 8080. So if you put column 8080, this will connect to the port 8080, but this should have an open connection for it, no? So there are some ports or some connections that you can test. I don't know if Google has the 8080 open. So the 80 is reserved for the website usually. There is a list of reserved ports. The 8080 is reserved for testing and other stuff. Let me see if there is port tester online. This is just to test if some ports are open. I think another port that is open, it should be the HTTPS port. The HTTPS, the S, yeah, it's 443. The HTTPS, guys, is a specific port that is used for the HTTPS. So HTTPS is a secure HTTP protocol because it uses a certified, it's certified. It uses a specific file that certifies that you are like that entity. So all the big websites are connected through the HTTPS. I don't know if we can try to do that. Oh, sorry.
That won't work.
Yeah, so if you do the same, so if you do google.com and then you write here 443, you are going to be redirected to the HTTPS Google. Yeah, so the secure connection. So this column that you see on the code is just to select here a specific port. Yeah. So in your local network, guys, you can expose any port you want. Let's say, but if you go outside, some ports are reserved for specific usages. So also your router translates your local network addresses to the outside internet addresses. This is what we call network address translator. So this means that your internal IP address and ports will not be corresponding to the external IP address and port. So maybe we can look some ports, some very common ports. I think SSH is 20 or something. No, it's the FTP. Sorry, 20 and 21 are the file transfer protocol. SSH is 22. For example, 25 is the one used by your email, and so on. So you can have a look to this one. Okay, guys, so this was a small Wi-Fi test. You also have the code ready-made that you can start testing it. And I'm not going through the I2C and serial because you already have done that, or you think it's good. So I think I will have it up here. Or we can go into C maybe.
Enough brain dead.
Okay, and just by using some libraries, but we should get also to some to see. So guys, I'm also okay to organize more sessions, more than one session during the week, where we go deep into topics if you want.
Yeah, okay. I'm still, I don't know about you guys, but I'm still trying to catch up on lectures that need writing and stuff. So I'm good for the moment. I'll have a go at this a little later.
Gerard, I'm sorry for my English.
No, your English is brilliant.
Sorry. Do you have questions or you want to use a specific module?
Me?
Yes.
I think I try this this one, the Funk.
The radio.
The radio.
The radio. Yeah, okay.
Yeah.
To start with, you can go to the examples. You just upload the code, and then it will work.
Okay.
In the wiki, in the local lectures, documentation, networking. Embedded networking examples. If you go here, you have example code. You just go to NRF24. And you have transmitter and receiver code.
Yep, good.
So you can download this and then you can modify the code according to your needs. For testing. Hannes, do you have questions? Brad, do you have questions? Things you want to add?
No, I think I'm good for now. I'll develop some questions over the course of the next days, I'm sure.
Me